area of quadrilateral. We know what is a quadrilateral. Given this quadrilateral, how to find the area? Okay. In the drawing, diagonal AC divides the quadrilateral ABCD into two triangles, that is ABC and ACD. That is, this diagonal AC divides this quadrilateral. This is that quadrilateral with four vertices, right? So look at this. You draw into two triangles, that is ABC. You have this triangle, AC, and here is another triangle ADC. Okay, these are the two triangles created by this diagonal. So to find the area of the quadrilateral ABCD, we got the two triangles, right? So if you find the area of the triangle 1 and area of the triangle 2, then we add up these two area, we get the area of the quadrilateral. So what is area of triangle? Half into base into height, right? That is base into height. So what is the base? Base is AC. So the AC is the base. Similarly, we have to find the height. PH is the height, right? Here we know what is AC here. This green triangle, base is what? AC, right? This is the base. In this, what is the height? From this point to this vertex point is the height. We have to find the height. Let us call it H1. So the formula says half into, remember the notation? The side opposite to this, we call it what? D, right? So in this triangle we call it D, in this triangle we can call it B. Something, anything is fine. Half into D into H1. This is the area of this triangle. Okay. In this area, how is this area calculated? ADC. This area can be calculated by half into base into height. So how do you calculate this area? The base is AC once again. This time you got to remember this is the height is dy, right? So we have to find the height from there by drawing a perpendicular, and we call it H2. So same thing, half into D into H2 is the height. Okay, only difference is here it is H2 and D. The base is equal for both the triangles, so it doesn't matter. Okay, adding up these two area, we sum these two, we get the quadrilateral area. As we talked, hence the area of this quadrilateral ABCD is the sum of two rectangles. This is the base, this is the height we saw, H1. This is the base, this is H2, right? So in a way we can write half into AC into, add these two heights. We saw D is the length of the base, H1 plus H2 is the two heights, square units. This is the formula we arrive at, okay, in finding the area of the quadrilateral. So area of quadrilateral is half of the product of diagonal and sum of the altitude to it from its opposite vertices. What it means? That is, we've been talking about the height h1 and h2. Okay, we add these two up and multiply with the base which is common, and then the area of the quadrilateral, we get it very easily. That is, to summarize, we can call it area is product of the diagonal to the sum of the altitudes, where D is the diagonal and H1, H2 are the altitudes. Altitude is the height drawn to the diagonal from its opposite vertices. When you look at it here, so it's half the product of the diagonal. Diagonal is what? This is the diagonal of the quadrilateral. So product of the diagonal, sum of the altitudes drawn from the vertices, opposite vertices. This is one vertex, this is another vertex. The sum of them length or height drawn from the vertices is what? H1 plus H2. So the product of the diagonal and to that of the sum of the lengths drawn from the vertices. Okay, this is what is the area of quadrilateral.